this is a question that they like to use on old tax tests and things like this. This is how much work is done in lifting a car. Now, so we are looking for the work value. We do know that we are taking a car and we are lifting it up. Okay, so the force that we are actually opposing is the gravitational force. Now we're going to assume that we're lifting this thing at constant velocity, okay, because it doesn't really make sense to accelerate a car up. So if this thing is moving at constant velocity, I know the force upward has to equal the force downward for a constant velocity to occur. So the force upward, I can actually say is equal to the weight. So now if we look at our formula, W equals Fd, I also have the formula F equals mg because we're talking about weight. So I can actually substitute that in and I can come up with a new working equation that I'm going to say is W equals mgd. Now, in this particular example, it says that we have a mass of 1,700 kilograms. So let's go ahead and say we have an M of 1,700 kilograms. We have gravity. We're going to assume that the car is on Earth because that's where all the cars that I know are. And we have a distance that we raise it as being 2 meters. So now once we have these three variables, so these three variables that don't seem to necessarily fit in this equation do when you combine these two together. Now a lot of times people will forget this 9.8 factor, and what they'll do is they'll just take the mass and multiply it by the distance. That doesn't work. Remember, if you were to look at the units, they wouldn't match at that point. And we'll show you what we're talking about in just a second. So now we would multiply this out, and we would say 1,700 times 9.8 times 2, and that's going to be equal to our work value. So we enter it into our calculator, 1,700 times 9.8 times 2, and we get a value of 33,320 joules. Now just to show you what we were talking about with the units, okay, if I would have just taken mass and multiplied it by distance, okay, what I would have on this side is I'd have kilogram meters. But on the other side, the unit for the joule, remember, is the kilogram meters squared per second squared. Those two things are not equal. So it lets you know that there's something missing. And remember, the unit of gravitation, or the acceleration due to gravity, is meters per second squared. Okay, when you add this term in, you clearly see that the units will match. You'll have kilograms, meters squared, and seconds squared. So please do not forget this G term. It's the most common mistake on this type of problem.